Back, guys, with our next set of examples for Module 6.1 and our next rule for logarithms, the quotient rule of logarithms. As we did with the product rule in our first video for Module 6.1, excuse me, I would like to compare what we already know about exponent rules to this quote-unquote new rule for logarithms. I'll put that up on the bottom of the screen here. Our exponent quotient rule, as you already know, is if we're dividing with exponents, we subtract the powers. Similarly and analogously, we have a logarithm quotient rule that says log base b of m divided by n, a quotient is the difference or subtraction of log base b of m minus log base b of n. That is, a quotient can be split into a difference of two logarithms, a difference of powers, since a logarithm is a power. So what do we do when we divide? We subtract powers. On the logarithm side, what do we do when we divide? We subtract logarithms. Those two rules are two sides of the same coin, the exponent form versus the logarithm form. And now we're going to apply that rule in a couple of examples here, as we did with the product rule in our first video, in our first set of examples, with question number 5, kicking us off, log of 7 over b. That single logarithm of a quotient can be split into two logarithms, a difference of two logarithms, log of 7 minus log of b. And that's all they're asking us to do here. Just expand and split this. Use your properties of logarithms, use your rules for logarithms to expand and split up a complicated logarithm into simpler pieces. They're not asking us to solve here. Don't worry, they'll be asking us to solve soon enough. But in Module 6.1, we're just getting practice with these properties. Question 6 is a bit of a step forward in terms of complexity. But let's work it. Log base 2 of 15x times x minus 1, all divided by 3x plus 4 times 2 minus x. And let's follow. This is going to take more than one step, but let's follow step by step and realize that first of all, we have a fraction. We have a quotient. And I can split that quotient up into a difference of two logarithms, like so. Log base 2 of the numerator, 15x times x minus 1, minus a separate logarithm, log base 2 of the denominator, 3x plus 4 times 2 minus x. Now we're not done, but what's left to do is something that we're already familiar with based on our work in the last video, in the examples 1 through 4 set, where we were looking at the product rule, because that's what we have left here. We've got products. We can use the product rule to split this up even further. Here in the first logarithm, we've got 15 times x minus 1. And we can split that up into log base 2 of 15 plus log base 2 of x plus log base 2 of x minus 1. And then we've got another product in the second logarithm, log base 2 of 3x plus 4 plus log base 2 of 2 minus x. So I'm just using my product rule to split up these logarithms into sums of separate logarithms, simpler logarithms. And looking at each of the individual logarithms that we have in this step, I've got log base 2 of 15, which is just the number 15 inside the parentheses, and no more simplifying can be done there, plus log base 2 of x, only x is inside the parentheses. There's no more simplifying I can do there, no more rules that I can apply there, plus log base 2 of x minus 1. Now in that third logarithm, the one I just read, log base 2 of x minus 1, I've got two terms. So can I split that? And the answer, I won't leave you in suspense, the answer is no. I can't split x minus 1 because I've got a quotient rule for logarithms, I've got a product rule for logarithms, I've got rules that say that I can split a fraction or I can split a product, but I can't split a difference into two separate logarithms. No. So x minus 1, that's as simple as I can make that logarithm. Log base 2 of x minus 1, we're done. Similarly, with log base 2 of 3x plus 4 and log base 2 of 2 minus x, there's no more factoring that can be done to split that any further. We're done. The only reason I haven't boxed that answer yet is because there's one step that we can take. We can distribute this minus sign. Distribute this minus sign across to these two logarithms because the minus sign here was applied to this entire logarithm in the first step. So I have to make sure that that minus sign gets applied to both the log base 2 of 3x plus 4 and the log base 2 of 2 minus x. That's just distributing a minus sign. That's all that is. And when I do that, I'll go ahead and read it, log base 2 of 15 plus log base 2 of x plus log base 2 of x minus 1 minus log base 2 of 3x plus 4 minus log base 2 of 2 minus x. And that's relatively lengthy, but that is as far as I can take it. That's as far as I need to take it. That's exactly what they're looking for as far as an answer here. Now in questions 7 and 8, we go the other way. We take a difference of two logarithms and recombine them, condense them into a single logarithm. Log base 9, number 7, log base 9 of w minus log base 9 of 5 can be combined into a single logarithm. That difference turns into a single logarithm of a quotient, w divided by 5. That's all they're looking for us to do here, to understand the relationship between a difference of two logarithms and a single logarithm with a fraction, with a quotient. Same thing in question number 8. The natural log of v plus 1 minus the natural log of x minus 9 can be combined into a single natural log of v plus 1 divided by x minus 9.